Welcome back, guys. So we'll start with the methods of linked list. So first let me show you how you can create a linked list. So for that I will create a new class, okay, and I will just write a main method main control space bar enter. So again here we can create the reference of list, same like what I did in the array list. We can supply the data is equal to integer, and here you write list, okay. So place mouse word here, and we do need to import the list interface which is available in the Java util package. Click on that, and then you write new and you write implementations of the linked list. So look at here, same like array list, linked list has two constructor. If you remember, in the array list there was three constructor in the array list. One was default, one was which will take the size of the array list, and one with the collections object. We will see that so that you can correlate. So one is this, which is of default, right? One more, you can create the object by supplying, so you change the reference. One you can create by supplying this list as an argument. So like you have two lists, so you can create one object by supplying the first list of object into second list, okay, because you have one constructor. The reason is, when you press control and click on linked list implementation, when you go here, it has two constructor. One will with no argument, we call it as default constructor. So when you create this one default constructor, I mean the default linked list object will get created, which has no size, okay. The another one, if you look at, when you create a linked list and when you supply the collections of object, that's what I tried the second one. Basically what it will do internally, see, it calls add all method, which means whatever collections of object you have supplied here, it will add to this linked list. It will add to the linked list, right? I will show you how it is. Whereas in case of array list, if you look at, see guys, why I was saying that you just need to change the reference. I can just write here list 2, same thing I can change the array list, right, of type integer. Everything will work as it is. Here I had to change the reference because here I am not commenting it. Otherwise I can just copy this and I can paste it. So my entire project implementations will work with no problem. See, I changed linked list to array list to linked list, okay, because our reference is the list. So the method which we'll use in the project, it will all belong to this interface, and both class implements the same interface, so there is no problem at all. Now look at here the array list, okay. We need to be focused here. In the array list, when you press control and click on array list, it has basically three constructor. One, this guy, which will take no data, it will initialize with initial capacity 16. One will take collections of data, second constructor, and the third, there is one more constructor, okay. See here you can supply the initial size of the array list. So there are three constructors, but this is not there in the linked list. Why? Because size is not required in the linked list. In linked list is all like object basis, node basis, right? So you don't need this. That is the reason you don't have it. Now list has the same method like what you had in the array list, add method. You can add here, let's say 4, okay. The add method will add the data to the linked list, same like array list. It will allow the duplicacy, okay. Now if I go and if I'll print CISO list 1, since I have created the second linked list object by taking collections of object as an argument to the second constructor, this object will get the entire data what first linked list has. So if I run that, this is the benefit. Sometimes you do get a requirement. See here, 44434, it maintains the insertion order the way you have inserted. So my second linked list, if you look at, I did not added any data, but still I am able to print that the region is, it is all coming from my first collections of object. Same thing happens in the array list. In array list, let's say this array list I have covered two constructor, one with the capacity, one is default. Here I am covering remaining one. The third one I did not cover intentionally. So here also in the list 2, if I'll go and if I'll use the same add method, just the thing is I need to change the reference, right? And now what I can do that is, even in the array list I can use the third constructor. I can supply the collections of object, right? So here also when I print array list 3, right, my array list will print the all data what array list 2 has, right? You can see that. Is there any difference? No. Output wise, no, there is no difference. For you there is no difference, but yes, there is a difference in the internal implementations which I have shown you. Now why I was always stressing on the point, make the reference of list and object of linked list. If you have any idea of like if your project is going to be changed or your project implementations part will change in the future, go make the reference as a linked list. If I will go here and if I will change linked list to array list, okay, and here if I will change array list to linked list, will anything will change in the output? No, of course not, right? Anything will change in the output? No. There is the same output, which means both the method is implementing from the list interface. It has their own implementations, but output remains same, right? Output remains same. Now when we should not use this? See, this is when we should use it, when you know that in future you might need to change the implementations. Yes, you go for the list reference. But let's say I need to use few method which is available only in the class, which is not available in the referenced class in the interface. Like in this linked list, I have a method called dot add. See, I don't have method here add first and add last. I don't have, because that list interface will not have that method add last, add first, right? Let me show you the difference. Okay, so here I have the linked list. What I will do, here you have a linked list of list reference, right? Here I will go and I will just change to the list. So this you know that when you create the object of reference of child class and object of child class, which means your child class will acquire all the method of parent class, so it will work as it is. Now on this reference, now it is linked list. Now reference is linked list, and you know that at compile time method call happens from the reference class. Now here I can call add first. See, you can look at here. Now add first method is coming here. Why it is coming now? Because this add first method is not present in the list interface, right? This is present in the child class only. If you have any doubt guys here, please watch my inheritance video or method overriding video. Everything will be clear what I am trying to say that here. My list interface, if I will go, if I will press Ctrl and click on list, if I will go to the method, press Command O, look at here, when you press Command O, there is nothing called add first here. So, and you know that at compile time method call happens from the reference class, so there is no method at all, you cannot call it, right? Whereas in case of, go back, in case of linked list, if you go and if you press Command O, here Command O, you have all the method implementations what you had in the list interface, because this guy implements list interface, so you will have all the implementations. Apart from that, look at here, add first, add last, you can see that add first, add last. This method you have only in the child class. When you click on that, just click on that, see this method is here, this add last method is here, add first method is here, right? Clear? So other method is coming from the parent class, but this particular method you will have it here, right? The other method, whatever you say, whatever you see, get, add all, so these all methods are coming from the implemented class. So look at here, here focus for some time. This linked list internally extends another class called abstract sequential list. Okay, it maintains the sequence. It implements the list interface, dequeue, clonable also I have covered in very details, guys, in my array list. And also I spoke about the complete concept of cloning, deep cloning, shallow cloning. I will not repeat here again. I have made a separate video altogether, how cloning works, how you do deep cloning, how you do shallow cloning. It's very detailed, so please go and watch that, right? And then serializable, which I need to cover. So that's how it implements. So when you implement clonable, right, which means you can clone the linked list, but it will give you the shallow copy. It will not give you the deep copy when you are using the referenced object. When you are storing the custom object in the linked list, you will always get a shallow copy, right? This everything I have covered in the details in the array list. Please do watch that video, cloning concept. So now it is clear here. When you have to use linked list, when you have to use linked list as a reference, when you have to use list as a reference, right? So when you are very confined to the specific method of the linked list, make the reference of the linked list, because you have a requirement where you have to use add first or add last, then yes, you need to go for the linked list. So the difference here is when I do add first and when I do 7, this will always add at the first. Okay, if I will add this 3 times, add first, add first, add first, and if you print this list, what you see is always it will get added at beginning. Okay, but when you use normal add method, it will always add at the end. So look at here, it is getting added in the beginning always. Okay, so how this works, whatever will be the last add first, it will go to the first. Now you can see the difference. The output will be 987 and then other data. See, 987. But when you, after that, when you call just add method, when you call add 40, the output will not be the same like add first. This guy will go at the end of the list. See, look at here, 40 came at the end. Okay, 40 came at the end. So that's a different add first and add method, right? Similarly, in the linked list, you have something called add last. So instead of add first, there is something called dot add last, right? This guy will always add at the last. So 90. So whatever you, if let's say if you have a 3 entry, whatever you have the last one, it will go to the last of that linked list. Okay, so it's like 9000, 70, 90. It's like same like add first, but this is in the reverse order. So this will go last, 70 will go after that, 90 will go after that, and then 40 as it is. So that's how this specific method of linked list will work: add first, add last. Okay, with this I'll close the video. In next video we will see that other methods of the linked list. Thank you guys, thank you for watching this.